All right, hello. Here we're going to be doing part 2 of our ROS tutorial. Now, in part 2, we're going to make some nodes, make some topics, have them published to each other, so that way you get your feet wet on how to actually make ROS programs and how to make them, Hi, quick edit here. I just wanted to correct something real quick. You're going to need to have ROS and Ubuntu already installed. There will be a link in the description of this video and in the previous video kind of telling you how to set all that up, but it's expected that ROS is already installed on your machine before you start this tutorial, how to make them, work. To start out with, we're going to be making a very simple program. We're going to have one program, the fax machine, which will read in user input from the terminal, send it across a topic, which I'm calling fax line, to a printer. And the printer will take that and then put it on the terminal. There's no real purpose of this program, but it shows you just very basics how to get working with ROS and how the very basics of it work. So in order to get started, you're going to need to pull up your terminal. And the first thing you're going to want to do is you need a workspace. In order to make ROS packages and work in ROS packages, you're going to need a workspace. So how do we make a workspace? Well, you just make a normal directory. So for us, it's going to be make dir -p, which creates multiple directories within each other. And we're going to just give it a name. And we want a source folder inside of it too. So now, if we go into tutorial workspace, we can see that there's a source folder. Okay. Now, this isn't a workspace just yet. It's just a folder. In order to make it a workspace, we type in catkin make. And that will do some very fancy things. And there we go. Now we have a workspace where we can actually work on things. Now, a workspace is not enough, though. We can't just make nodes on their own. We need a package in order to put nodes into. So in order to make a package, it's a little bit more involved. We're going to need to go into our source folder that we made. And we're going to need to type in catkin create package. Now, the parameters to catkin create package is first off a name. So for us, we're going to do turtlebot. And then I'm just going to call it turtlebot tutorial. And we're going to put all of our nodes in one package for now because we don't really need to do anything more fancy than that. And we're going to need just a few dependencies. The next arguments are dependencies. Dependencies are just the parts of ROS you'd like to use. So messages need to be defined. Topics need to have a defined set of messages. But there's a lot that ROS already gives you. So we're going to need the standard messages, which are just easy messages that everyone will want to use. And we're also going to want... Man, I am really having a hard time spelling today. Geometry messages. Which give you things like vectors, things like that. They're really, really useful. I would almost always import geometry messages. And you're also going to want the Python library, so ROS.py. This should be all you need. And if you type in enter, it'll create it. So now we have a folder, turtlebot, which is our package. You're only going to want to make one more thing. Inside of your package here, where you see source. Source is for C++ files. Since we're working in Python, we're going to want to do make dir scripts. Scripts is where your Python stuff goes. Perfect. Now we're set up and we're ready to go to make some code. So you can use any text editor you like, or IDE. I like Visual Studio Code, so I'm going to bring over Visual Studio Code. We're going to open a folder. And so for us, I'm going to go into programming, or just go wherever you made this. And for me, it's going to be in the tutorial workspace, and I'm going to hit OK. And now I have it open in Visual Studio Code. I'm going to browse to my scripts folder. I'm going to make a new file. I'm going to make the faxer.py, and let's make a printer.py. So these are our two files. And the thing to note about this is these are two Python files like any other two Python files. So let's just write out some very basic stuff, and then we'll modify it to fit with ROS. So the first thing is you're going to need to put the shebang, which I always forget, but I think I'm just going to copy it, and you can just copy it from my screen. The shebang just tells when you run this program, like what to run. So for us, it's going to be user bin Python. And then let's do this. So this is a very basic Python thing. You should know Python before doing these tutorials. So this just tells us what to run at the very beginning. And what we're going to do is we're going to have a function where all of our code goes, and we're going to call it faxer. And all of our stuff goes here, and we're just going to run faxer. That's it. This will start up faxer on startup of this Python program. So it's just a Python program. Now, for now, let's just make our message constant. So message equals hello world. Okay. And we want to somehow send this to the printer. Now, that's not too hard. Let me go over here. This is our printer now. And let me change up the name. Printer. Now somehow we want to print, very easy, print the message. Okay. How do we ROSify these two programs to work with ROS? First thing you want to do is you want to import ROSPy. I'm back into Faxer, by the way. So we want to import ROSPy. And we want to import one more thing from ROS. We want to import standard messages dot message. Oh, sorry. From the standard messages dot message, you want to import string. And what that means is we're going to send a string topic. We're going to make a string topic. And that just means you're sending, words, strings across between the two nodes. So there's a couple things. Before you can use ROS functions, you have to let ROS know that this is a node. So we're going to do init node, and we're going to give it a name. For us, it's going to be faxer. And we're also going to make it an anonymous node. This is a kind of a more complicated topic, but essentially, anonymous means it doesn't need to be necessarily only one of it. You can spawn many of them, and there won't be any conflicts. We'll get more into it later on in the series about what this means, but for now, just include it. And okay, now we have our node. We're in ROS. We have ROS. Now, we want to send this message across a topic. So let's make a topic real quick. The way we do this is we need to store the topic in a variable. I'm going to call it pub for publisher. And we're going to say rospy.publisher. And this will make a topic. Now, we need to give this topic a name. For us, I'm going to do fax line. We need to tell it what we're sending across this topic. It needs to be a message type. We're going to do string, which is what we imported here. We're going to tell it this is our message type. And then we need to give it a queue size. A queue size is how many of these messages are we going to store before someone starts reading them. So we're only going to store the 10 latest ones before someone starts reading them. This is, again, a more complicated feature. You don't really need to worry too much about it, but it's going to store 10 messages before starting to get rid of some, before someone else, aka the printer, reads them. Okay, here's the thing. I don't want to send hello world once. I want to send it an infinite number of times. So let's do, you could do while true, which will just run forever. But there's a more ROS way of doing this. We could do while rospy.is shut down while it's not shut down. Basically just means, hey, keep running until ROS tells you to stop. That's all it says, which is exactly what we want. So this will make an infinite loop. Now here's the thing. Do we really want to be pumping out messages as fast as the CPU lets us? No, we want to have some sort of limit. Now, ROS has a great way of doing this too. We can set a rate at which you run. So what you can do is you can say rate equals, which is just a variable, rospy.rate. And you can tell it at how many hertz you want your program to run at. I want it to run at 10 hertz, which means this loop will run at 10 hertz. How do we make the loop run at 10 hertz? Well, all you have to do is call rate.sleep. And that's it. Now, this loop is running at 10 hertz. Now, we want to take our message and we want to give it out to the masses. How do we do it? Remember this variable we made for the publisher? All you have to say is pub.publish, and you want to just put your message in there. There we go. This is a pretty simple ROS program, and hopefully you understand how it works. Now, there's one more thing you want to do just for safety. You want to put this in a try-catch block, so that way if anything goes wrong, it's easy for ROS to figure out why it went wrong. We're going to accept, and we want to catch. ROSPy has its own exceptions, so the one we're going to do is ROS interrupted exception, or ROS interrupt exception. You just want to pass on this. There's just some really quick and dirty error handling code, so nothing freaks out, and this is just good practice. So we had any other Python program, and what we did is we published this message. And now it's out in the world. So now let's write the counterpart, the one that's going to capture the message and print it. Now, this is a little bit more interesting because things are going to be similar but also different. the first thing we're going to want to do is we're going to want to do the same thing we did last time, which is to make a node. Also, yeah, we also want to import ROS.py and from standard messages import string. Apologize for my loud keyboard, by the way. It's probably very annoying, but not much I can do. Yeah, you want to do init node. I want to give it a node. In this case, it's going to be printer, and we're going to want the same thing, anonymous equals true. We have a node. Now, how do we set a message variable? Well, not that simple. What we want to do is when you get a message, the way ROS likes to handle it is it likes to call a function to deal with the message. So let's make a function, and we'll call it fax handler. So this is handling the fax. And what we want it to do, it'll take in a data thing. Now, data is going to be whatever the topic type is, so string. So data is of type string, which is the standard message type. And what we're going to want to do is we could do print data, which is really annoying. These things can break down in a million ways, and we're going to want to Google how these work. So string.data is going to be what the actual contents of the string message are. So if you do data.data, it's basically doing string.data, and you can print it out. We could do print, which is totally fine, but I want to make this even more ROS-y. So what we're going to do is we're going to use the ROS version of print called ros.loginfo. And the reason this is helpful is because this can write it to a file if we set it to that. So if we don't have a terminal, we can read it back later. But for now, this is just going to act like a print. So ROS log info. Now, we need to tell it to listen to that topic. How do we do this? Well, like all good things, it starts with ROS.py. And what we're going to want to do is we're going to call a subscriber. The subscriber needs to know what it's subscribing to. In this case, the fax line. If you remember, if we go back to the publisher is called fax line. This is called fax line. It needs to know what type of thing it's expecting to get. And in this case, it's going to be a string. And the last thing is we want to know what function should handle it. So what the callback should be. And we're going to say the fax handler should handle this. Now, let me delete this. The only thing we need to do is we need to make sure that this if we just did this like this right now, it would run this and then the program would shut down and it would never work. So we need to tell ROS, okay, keep this alive to listen to stuff. And there's an easy way to do this. ROS.py.spin just keeps the program alive. It's not doing anything, but it'll stay faithful to its subscribed topic. So it'll keep the subscriptions going, but it won't keep the program wasting CPU space. So there we go. You can also surround this at a try catch, but since the reason that we did a try catch in the last one is because we're going to be waiting for a shutdown message, so we want to be able to catch the shutdown message. Here we don't need that, so we don't need to try catch anything. And there we go. We now have a set of ROS programs. Let's pull up our terminal. Let's go back to the very origin of the workspace, the tutorial workspace itself. And we'll run catkin make again very quickly. This will just make sure everything is compiled, even though Python's not compiled, but you still want to do it to make sure your variables are there. Now, this is something very strange about ROS. When you want to run things in ROS, you need to make sure you're doing what's called sourcing your workspace. So what you're going to want to do is you want to do source devil/setup.bash. And this will update your environment variables so ROS understands what you're working on. You need to do this. And you need to do this once per terminal instance. Here's the thing. I'm going to spawn up another terminal. And actually, let me attach it. Basically, we're going to want two terminals. One here and one here. One will be the faxer and one will be the... Oh, I just love Ubuntu. One will be the printer. Let's do the same thing here. We're going to want to do... I navigated a tutorial workspace. And what we're going to do is we're going to do source devil/setup.bash. So these both know what we're doing. And now, oh, sorry, I forgot. One more critical thing you need to do. These Python files, when you created them on Linux, are not runnable by default. You need to tell the operating system these are runnable files. So what you want to do is you want to do chmod +x, which tells to make a program executable, and you want to find them. So the way you find them is you could do source to whatever the package was called, which I think was turtlebot.tut, and then you want to go to scripts and then faxer.py, and you can do the same thing with printer.py. So now these are executable. +x means chmod means change permissions. +x means make it executable. And then I just found the path to the faxer and the printer. So now they're runnable. By the way, I cleared my thing by saying Control-L. And I probably shouldn't have done that. You could probably go back in the video and look at it if you wanted to look at those commands. Okay, now let's run things. In order to run ROS, we're going to need to start up a third terminal, which I have running here. And you're going to want to tell ROS as a whole to start running. The way you do that is you type in ROS core. And now ROS core starts up ROS in the background. Now, if we want to run the printer, or the faxer, sorry, you say ROS run, it's a command. You want to specify the package. So here it's going to be turtlebot tutorial. And then you want to tell it what program to run from in there. So that'll be faxer.py. And oh, I forgot to do something. Let's take a look at what my error was. It was in faxer, and oh, would you look at that? I forgot to put one of these. Incorrect syntax, folks. It'll get you. So let's try and see if it works now. Oh man, I'm really gooning it up. Okay, some other fixes that we have to do. We have to make sure we put these on name. Let me make sure I did that over here. Nope, I didn't. This is basic Python stuff, but here you go. That should be the last issue. Probably there's one more. Let's see. Oh, there we go. So now it's running. Faxer is running. We're not printing anything from Faxer. So now let's do the same thing over here. ROS run turtle now printer.py. And oh, I'm lazy. Forgot to do dot message. This is required to get this to import properly. My apologies for the mistakes there. Let's run this one more time. And there we go. So now this is sending hello world, and this is receiving it, and it's telling us it's printing hello world. Let's modify this a little bit. And this is a challenge I'm going to give to you. I challenge you, pause the video. This is not a very hard thing. Pause the video and modify this so that it will, instead of just printing hello world, it'll print from the a user input. Go ahead and try it and pause the video. Okay, if you went and you tried it, let me show you how I would do it. We're in Python 2, so we're going to want to do raw input to get input from the user, and we're going to say, enter your message. And now nothing changes. This is still a string, so message when you publish it, it'll turn into a message, and everything should stay the same. And like I said, we didn't have to modify printer because it knows what it's receiving. You just had to modify faxer. And let's try this real quickly. Let's stop all of our programs and run this. ROS run faxer. And it's gonna ask me for my message, and let's start up the printer. Watch this. Hi. Hey, take a look at that. ROS is super cool. ROS is super cool. There we go. We can type whatever we want. And these two processes, these two completely separate programs, are talking to one another through the magic of ROS. And as you can see, it's not too complicated. The most difficult part was really getting the workspace set up, which isn't too bad. And after that, typing the programs is just like any other Python program, except with a little bit of extra stuff on top. I hope this made sense to you. I hope that this helped you kind of get an understanding of what we're doing. And from now on, I'm going to be showing you, we're going to keep this tutorial workspace, because that's what we're going to be working in. We're going to make new scripts, and we're going to make them do even bigger and better things. And you'll see that you don't even need to do that much to get it to do much more, because the other parts are all in this ROS framework. So everything will come together. I hope you've enjoyed this. I hope it's been educational. Sorry for the typos there, and sorry for my loud keyboard, but hopefully it was still a helpful video. And I'll see you guys next time, and we'll start working on gazebo simulations, and using these techniques, the same techniques we worked here, to get a real robot moving around.